Hi guys, so just waiting for more persons to log on, and as soon as we have a few more persons, we're gonna jump right in to today's session.
Okay. Any idea what session we're doing? So if any papers to be printed?
Let me send you the schedule for the rest of this week because this week is our last intensive revision, and then next week is just revision generally. So today we're gonna focus on question 3. Tomorrow we're gonna focus on construction. So constructing triangles and different shapes using your geometry set. Tuesday is question 6. Wednesday is question 8. Thursday is another paper 1. And then next week is all summary notes for revision purposes. So that's what this week is all about.
Okay.
I'm going to repeat it once we have more persons. Like I said, question 3 has been a bit tricky. I've been looking at the trend of the past paper, and from what I've seen, when they bring construction in January, they bring it in June, but they have not bring any construction in a long time. And so I'm feeling like it's important for me to ensure you guys at least know it. If it doesn't come, it doesn't come, but at least if it does come, you guys would know what to do. So yeah, after we finish that this week, we have covered every single thing and we could focus in on the weaker areas. So just gonna wait a few minutes and then we're gonna get started, okay?
Okay, no problem, Miss B. Good afternoon, Myrtle.
Afternoon, Janelle. I see you come out the doghouse. I see you get up Miss the doghouse.
Yes,
Janelle, you get out the doghouse.
yes, I had to very quickly.
That's good, that's good.
Can't they wasting time, eh? Even though we're busy.
That's right. You're wasting the time. You want to go in the doghouse at all.
It's true. But this child that I get here does get me so busy sometimes. She is so active. I just be so tired. So tired.
Okay, okay.
She ain't even 2 yet.
All right, so let me just begin today's session by saying that question 3 is one of the more challenging. It's not the most challenging, but it's one of the more challenging questions because it deals with transformation. And for those who aren't aware of what transformation is, we have not covered it, but we're going to try to touch on it a little bit today. So it's about objects that are moved left and right on the graph, objects that are increased in size, which we will call an enlargement, and then reduce in size, which is a reduction, and also rotate it around the graph. So today we're going to try to look and reflect it. So those are the ones that we're going to be looking at. So today we're going to use our FastPass exam questions and notes to kind of make sense of it, because the truth is most people skip this question, but let's say the question is 10 marks. You should always try to get 5 at least out of this question. Okay, so mentally prepare yourself. It is tricky, but it's not impossible. And We're just trying to get as much marks as we need to ensure we have a great mark. All right, so we're gonna get started. Just give me 1 minute and then we're gonna start. Yeah, I'm muted, that's why. So let me know if you could hear now. We're gonna get started. So let's go, guys. If you could hear and you can see and you're ready to go, just say something, say something, say something. All right, so let's look at question 3. Question 3 is geometry and trigonometry 1. As we know, there's another question 9, which is also geometry and trigonometry, but that's the one that deals with circle theorem, that's bearings, angles of elevation and depression, cosine rule, sine rule. Okay, so that's a separate thing. So question 3 deals with types of shapes, their properties. It deals with transformation of these shapes. And other small stuff that we need to just pay attention to and remember. All right, so if you guys are ready, we're gonna jump straight into it. So this is the question from January 2022, that this year that just gone. Now, one of the things I want y'all to pay attention to, right, is that, like I was saying earlier, there's a trend. Sometimes the January paper is like a clue to things that you should expect that's coming. You can't really trust it, but just looking at the pattern that CXC sets, it generally reflects what will be coming. So while we do this paper, I want us to pay special attention. So I'm going to take my time and go through this paper. And the reason is for that is to make sure everybody understands what we're doing and what is happening. Okay? Sounds good? If you have any questions, make sure you ask, because again, this would be the foundation to all the exams that we do continuing for this afternoon. All right, so let's jump right into it. The box below contains the name of 5 quadrilaterals. Now, be honest, out of these 5, out of 5, how much do you know in terms of how it looks, the properties, the way that the angles are? So out of 5, is it 5 out of 5, 1 out of 5? What is your score with these 5 quadrilaterals? Okay, I see one person saying 3, one person saying 3. Let's go, everybody. Give me an idea of how much you know about each. About 3. Okay, so it's important because you can't understand how to answer these questions if you don't know how all of them look. So first thing first, let's start off with the most basic one, which is what? The square. What do we know about the square? We know that the square has how much sides? All of them have 4 sides, but the specific information about the sides are what? All of them are what? Equal. All of them are equal. And what are the angles inside of the square? Because these are the things we also need to know. All of the angles are what? 90 degrees. Everybody see now? All right. Next one. What other shape that we are familiar with? The rectangle. Similarly, all of the angles in a rectangle are what? 90. But what's the difference with a rectangle? The rectangle, the opposite sides are equal. So all of the sides are not equal, but the opposite sides are equal and also parallel. Let's keep it moving. What about the rhombus? Everybody know the rhombus? What's a rhombus? The rhombus is a parallelogram. It is almost like a leaning square. A rhombus is like a leaning square. So what about a square do we know? All of the sides are equal. The only difference between the two is that the angle in the rhombus are all different. Everybody see that? Well, let me don't say different. This angle here is equal to this angle here. These two angles are similar and these two angles are similar in a rhombus. But what is the same property? All of it has what? The same sides. So this is what we have our rhombus. So we have square, we have rectangle, we have rhombus. Do we know what a trapezium is? If you don't know what a trapezium is, please confirm now. Let me know, guys, if you know what a trapezium is. Confirm or deny. A trapezium is a quadrilateral that has only one pair of parallel sides. We went through the formula for a trapezium in the measurements class when we found the formula for the area of a trapezium. So as we see here, the difference between this and this is that these two sides, one of the pairs of the sides are not parallel. Everybody see that? So they're one pair of parallel sides and they have a name. This is A, this is B. And in between the two parallel lines, we call that the height, the perpendicular height, which we call H. Everybody with me? Make sure you're with me, make sure you're because this is important. So we now see what a trapezium is. Please note that it is possible for the trapezium to have a 90-degree line. So let's say this line here could be a straight line like that. What is the most important property about something to make it a trapezium? It should only have one pair of parallel sides. Okay, so sometimes it looks like this and sometimes it looks like what it was before. Now, a kite, everybody should know how a kite looks. Four-sided, obviously, but the difference is that it has two pairs of equal lengths. So this is how the kite looks. And there are some lines that we need to pay attention to. Everybody should know what a diagonal is, right? A diagonal is when you draw a line from two opposite points. So this would be one diagonal. Let's pretend that it's going straight down to the point, okay? Because I could never get it connect properly. And this is another diagonal. Everybody see now? What do we realize about the kite? That these two lines are equal and these two lines are equal. So that's the imagery in your mind that you should have when it comes to those shapes. Let's look at all of them again. So everybody good now? Everybody 5 out of 5? All right. Similarly, you have to know the different types of triangles. So I hope you know all of the triangles. So we have an equilateral triangle. We did this before. The right angle triangle, the scalene triangle, the acute angle triangle. All of those are the different triangles that we did. All right, so let's look at these questions now. Choose the name of one quadrilateral from the box that best completes each statement. A dash has no lines of symmetry and has rotational symmetry order of 1. Now, these are some important words we need to look at today. Lines of symmetry, rotational symmetry, order of 1. So first thing first, we've come across symmetry before, but how many persons do not know what symmetry means? Don't be afraid, because I need to know how to explain this and how deep to explain it. Okay, perfect. Now, symmetry means, right? Let's say I draw a triangle here. Let's pretend that this triangle is equal sides, whatever, right? The line of symmetry, oh, people waiting to come in. Guys, if y'all realize people are in the waiting room, just give me a heads up, okay? Because sometimes I just get really focused with the lesson and forget to add people. Y'all can see people in the waiting room too? Or just me?
Just you.
Oh boy, okay. All right. So as I was saying, when you have a line of symmetry, is when you could cut the shape in half and both sides are equal. Everybody see that? So if you look at this triangle, I could fold this triangle onto it itself, and the half gonna match the half. Everybody see what I mean by symmetry? So for example, if I were to take a sheet of paper, computer paper, I could get the line of symmetry, but I could get more than one. So for example, let's look at the square. How many lines of symmetry can I get? And I'm going to draw a new square. I wish I could have just draw shapes. Can I draw shapes with this? Hold on. I don't think so. But for the interest of time, I'll just draw a shape, a square. So let's draw this square. Let's pretend that it is all equal sides for the purpose of explaining. All right. How much different ways can I fold this shape so that the sides are matching? First thing first, I could fold it like this, down the middle like that. Everybody see that? That's one. So that's one line of symmetry. Everybody with me? If you're with me, just say got it quick. It also means that, same thing with the internet. Let me see if I could switch over to another internet, because this one acting funny. So it might drop for a few seconds, guys. Just give me a quick second. Let me switch over to another internet, okay? So that we don't have that drama happening. All right, you guys hear me? Hopefully this Wi-Fi, this other one should be a little better. So we shouldn't have any issues with the Wi-Fi dropping, messing up my flow, and all these things. So just confirm that you're hearing and seeing again, so we could get back into it. All right. So as I was saying, this would be called one line of symmetry. And the truth is, the rotational symmetry means that if we take this and flip it like this, would the image look like this again? Everybody see that? Everybody see what rotational symmetry mean? If I were to flip this once this way, would the image look like the same way it was when we first had it? That's what the rotational symmetry mean. And in this case, yes, it does. So we have, yeah, because remember it's a square. So it would turn over in the same way. Let's look at another line of symmetry. If I were to cut it halfway along the other middle line, Isn't the top and bottom sides the same now? So how much lines of symmetry do we have? 2. Is there another way I could fold this paper for the sides to match? Yes, I'm going to use a different color. I could go from corner to corner. I could fold it like this and both sides will match. Excellent. I love the word diagonally. And I could fold it the other way around. So essentially, how many lines of symmetry do we have? That's 1. That's 2. That's 3. That's 4. Everybody see how we find the line of symmetry? And in your mind, you need to think about folding. If I was to fold this, would everything match up on both sides? That's what the line of symmetry is. Rotational symmetry means if I am to rotate it, would I get back the same position? So let's look at the shapes where we're at it. How many lines of symmetry do we have here with this rectangle? Because it's tricky, eh? Let's zoom in a little bit. How many lines of symmetry we have? Make a guess. Excellent. We only have 2. You know why? Because yeah, we could fold it. Oh no. Let's get a straight line. We know we could fold it like this and we get matching sides. We know we could fold it like this and get matching sides. If I fold this paper like this, would the sides then match? Look at it. Ain't matching, in it. It's not going to align against each other. So this would not create a line of symmetry. So here we see the difference between our square and our rectangle. Our square got us 4 lines of symmetry, whereas our rectangle only gave us 2. Everybody with me? If we look at this kite, how much lines of symmetry this kite got? Let's see if we're thinking. Excellent. Only 1, because I could only fold this paper this way for both sides to be matching, for it to have a mirror line. And I hope you are seeing the words I'm using: mirror lines, reflection, right? So these are the things we're looking for. Similarly, rotational wise, can I rotate this? How much times can I rotate it to get a matching figure? I could only rotate this once, which is all the way around, because there's no other position this could hold where it go back to the same position. Everybody see that? Whereas this, I could flip it 4 times and it would always end up in the same configuration. This one, how many times can I flip it for it to get back in the same configuration? 2. That's it. That's it. So let's get to this question now. So before we get to the actual question, everybody understand what you should be thinking when you hear line of symmetry now? Because we've done line of symmetry before in graphs. If you think about it, when we did the graphs like this, didn't we used to find, we did it once or twice. We had to find the line of symmetry of that curve. All right, so let's go. So it says here, which one has no line of symmetry, none, and has a rotational symmetry of 1? So everybody take a guess. I don't care if it's right or wrong. I just need y'all to start thinking. Which one would never give us a line of symmetry? The trapezium, the rhombus, the square, the rectangle. Everybody make a decision. So we have 1 trapezium, 1 rhombus, 1 trapezium. I like where we're going because we need to think. All right, so let's look at the notes. A trapezium has no line of symmetry and has a rotational symmetry of order 1. Let's look at the trapezium. Can I fold this in any way for the sides to match? Never. I can't fold this way. Let me make sure I show you because it's visual. If I fold it this way, it's not gonna match. Everybody with me? If I fold it this way, it's not gonna match. So that's not a line. If I fold it so, it's not gonna match. If I fold it diagonally, it's not gonna match. So here we see that this shape has no line of symmetry. Everybody with me? No, and then obviously it must have an order. It must have an order of 1. Why? Because the only way to get a shape back, if I rotate this, spin this around, the only way for me to rotate it for it to match is for it to go all the way around. That's why the order of rotation is only 1. Everybody see that? Whereas, look at the square, the order of rotation is 4, because no matter which side I flip it on, it's gonna look the same. I could flip it on every side and it's going to look the same. Everybody see what I mean now about line of symmetry and line of rotation? So we see here that this specific shape, the answer is a trapezium. And just because I want to make sure we understand, let's read through this so that we're on the same page. A trapezium was considered the best fit. Although strictly speaking, it has no rotational symmetry. That's true, because it's all the way around. You have to flip it for it to be able to match its original position, right? Rotational symmetry of order 1 does not really exist. If a shape matches itself only once after a full rotation about its center, then there's no rotational symmetry. Everybody see what it's saying? So technically, yes. Excellent point. I hope everybody saw what Niall said. I'm not sure if he sent it to me or not, but I hope y'all understanding how this works. Okay? So let's move on to the next one. A dash has exactly 2 lines of symmetry and 4 right angles. We did this. Which one it is? A dash has 2 lines of symmetry and 4 right angles. If we look at our option, only 2 of them have right angles, the square and the rectangle. But we know, as we saw, the rectangle has way more than 1 rotation line of symmetry. And we saw it with the rectangle, it has 2. So obviously the answer is rectangle. Everybody see how easy it is, to be honest? All right, so excellent job. Next one. A dash has 1 line of symmetry, but no rotational symmetry. Which one? Even though the answer here, but you know what I'm saying? We know why, because we don't talk about it. It must be the kite. The kite has 1. Everybody see that? And the only way for it to come back to this position is because you have to go around. Everybody see it? Everybody with me? Talk to me, talk to me. And to be honest, it's the only one. Yeah. Okay, excellent. All right, now let's get into the nitty-gritty. I love this question because this is a basic geometry question. So before we get into it, what type of lines we seeing? The first lines you should see is a specific type of line. What type of lines are they? Excellent, parallel lines. I hope everybody's seen them. What indicates that they are parallel? The arrows. You could never say they're parallel, even if they look parallel, if they do not have the arrows. Okay, we've learned a lot of different angles based on these lines. Anybody remember them? The Z shape. So let me get a different color. So we have the Z shape. And everybody should remember what type of angles are affiliated with the Z shape. Alternate angles. Everybody with me? Another type of angle affiliated with that is also in co-interior. So I am already seeing the 2 co-interior. I am already seeing my 2 alternate. Everybody with me? Another type of angle I'm seeing, so co-interior, we're going to identify it soon. Another type of angle I am seeing is vertically opposite. So everybody, let me know out of the 3 how much you're seeing. So if you have 3 out of 3, let me know. If it's 2 out of 3, 1 out of 3, let's go. Are you seeing the 3 different angles? The alternate, the co-interior, and the vertically opposite. Okay. I'm taking a minute just to see, because I don't want to just tell you. You're supposed to be in the zone where you can first. So let's go, let's go, let's go. Let's go, let's go, let's go. How much do you see? Okay, so let's go. First thing first, everybody see the alternate? Look at the Z. Which 2 are alternate? This and this ain't the alternate angles, because they're in the creases of the Z shape. Talk to me, talk to me. Good. Now, let's look at the co-interior. Remember, the co-interior is in between the parallel lines, but you see how the alternate on the opposite side? The co-interior is on the same side. Everybody seen it? So let's just remember, alternate angles are equal, and co-interior are what? Co-interior are what? Supplementary. And supplementary means what? That both of them add up to 180 degrees. All of this is revision. So as we see here, alternate, the creases of the Z, they are equal. And co-interior are supplementary. That means both of them add up to 180. Anybody seen the vertically opposite? Look at the vertically opposite here. When 2 lines intersect and they face each other, they are equal. They are vertically opposite. Yeah? Everybody seen all 3 now? And vertically opposite angles are equal. So let's look at the actual question now. So to be honest, we should be able to find we answers them quick. So I hope everybody who did not see them before, see them now. Remember, geometry is about the eyes. Seeing is important. All right, so let's go. First question, determine the values of Q and R. So let's look. Which one they ask us for? Q and R. Which one is the easiest one to find first between Q and R? R, because they're equal. If here is 54, here is 54. Work smart, not hard. Next, now that you know this is 54, we already identified that Q and R are co-interior. That means they add up to what? I didn't ask for P yet. I didn't ask for P. Remember, the question asked for Q and R first. The question asked for Q and R first. So as we see here, Q and R are going to add up to 180. So what would you write? Q, and please remember how you set down your work is even more important than the answer. Q, and you will say here, R is 54, and you're going to state the reason, right? What's the reason? Vertically. No, I am writing VO. Nobody go write VO in the exam, okay? Do not go write VO in the exam. In class, you know what it means. In the exam, write out the entire word. Vertically opposite to 54 degrees. Okay, that's your answer. Q is equal to 180 minus 54. What's my answer? Make sure you got your calculators on standby. 126 degrees. And what's the reason? Co-interior to R. Hence, supplementary. Don't forget, use your fancy words. Hence, therefore. All right, so everybody got this unlocked? Let me know if you're good to go. Quick, so we could continue moving along. Quick revision of basic angles, basic angle rules. Just want to take this moment to also remind you of what complementary means. Complementary means they add up to 90. Keeping in mind the angles in a triangle, the angles in a triangle add up to 180. The angles in a quadrilateral add up to 360. Okay, these are all the things we need to know. Keeping in mind as well, if you think you have a good grasp on time management, the more you're right, the more chances you get with increasing your grade quality. Okay. All right. So let's keep it moving. Now, this is where we getting into the real nitty-gritty thing today. Transformation. For those who don't know, there are several transformations that we should be aware of. Let me just quickly take note of them. First one is the easiest one, translation. We've actually done it in vectors. Anybody remember what translation is? If I have an object here and I move it here, it was moved a certain amount to the right and a certain amount up. So remember, we used to represent that as a vector. That's translation. So we know if X is positive, where is the shape moving? To the right. If X is negative, where is the shape moving? To the left. If Y is positive, where is the object moving? Up. If Y is negative, where is the object moving? Down. Everybody with me with translation? That's the easiest one. Next one that we're going to look at, which is also easy, is reflection. And we should all know what reflection is. If you have an object, let me see. You always have a mirror line, and everybody know what the mirror line is. Just like the line of, similar to the line of symmetry, but it's in relation to the object. Hello? Who am I talking to? So let's get some confirmation if we understand the concept. So if I have a reflection, I'm just going to try to make it look. I'll try nothing. Anyways, I try a thing. The purpose of this is she's not seeing it inside Google Classroom. That's weird. Let me just take a picture. Give me a minute, guys. All right. So I just want to take this opportunity also to let you know that when it comes to paper one, we only got one more session for paper one. Based on the results I saw, I'm actually very, very pleased with the results. I know a lot more persons. You could ups up your grade a little bit. And I'm going to be honest with you. Here's the trick to do so. I have all the answers to all the papers, right? You could actually go through all, just read through and try to memorize. I won't say memorize, just make sure you understand the questions. But the truth is, you can memorize them, and most of them, it would help you remember. I would not recommend it because I prefer learning and understanding so that no matter what comes, you understand. But if you know you're super, super, super weak, I think it's important for you to go through all of the papers and all of the answers so you could pick up on what you're not doing well in and you could fix it. Okay. So that's just a quick hint. We have 2 more weeks to go. And I'm only doing it on an individual basis. So if you want it, you ask me and I send them to you. Okay. All right. So as we were saying, reflection. One of the properties about reflection is that the image is inverted. So what does that mean? If this is the front, on the other side, the front is going to be here. Unfortunately, my diagram is not good because the distance between the first point and the line of symmetry should be equal. Everybody see that? Everybody with me? That's a property. And as Myrtle said here, in this specific example, the line of reflection or the axis of reflection is the y-axis. And so if I were to draw the x-axis, you should be able to sketch how this image is going to look after being reflected, right? So you know this point is going to look like something so. Everybody agree? So these are the type of things you need to have in the back of your mind, okay, when it comes to reflection. And the truth is, there's only 3 types of reflection that you can have. Well, you can have several. You could have the axis, which is the y and the x. You could have reflection in the xy line. And everybody remember what the xy line is. I explained it already. Talk to me if you know what the xy line is. Y is equal to x line. If I take any point on this line, the x and the y points match. So if here, this number is 5, when I go down, this number is 5. If I choose a point here and that's 7, come down, this gonna be 7. So x and y match for each point on that line. Everybody see that? Similarly, there's another version to this in the opposite direction. What do you think the name of that line gonna be though? Y is equal to negative x. Look at it. That ain't true. Because what side of the x-axis we on? The negative side. Please know these things. You need to know these lines. You need to know the names of these lines. I'm going to also take an opportunity to show you and remind you about lines, the equation of straight lines on the Cartesian plane. So let's say this is 3. X is equal to 3, because we know this is the x and this is the y. If I have a straight line passing through 3 only, what's the name of that line there? The name of this line is what? X is equal to 3. Everybody with me? Similarly, if I had a line going across, maybe I should use yellow. If I had a line going across at, let's say this is 0.5. What is the name of this line? Let me see who with me. What's the name of that yellow line? Excellent. Y is equal to 5. And you know what's most important? You have to say is x is equal to 3 here. You have to say y is equal to 5. Everybody with me? We should also remember the name of this point here. What's the name of this point here? 0, 0. What do we call that? It has a name. Excellent. The origin. All right, so those are the 2 simple, straightforward transformations. Translation is like sliding the object up and down, left and right. Reflection is literally what it is, reflecting the image using some line of symmetry. This line of symmetry can be either the axis or another random line. Let me ask you a question now. What is the equation for the x-axis? Because I went through this a lot of times. If nobody knows, that's okay. That's why we're here. And I kind of teach you a trick about remembering. Y equals 0. What is the equation of the y-axis? Then x equal to 0. Thank you very much. Thank you so much, ladies. Everybody with me? These are things we cannot forget. Sometimes people in the exam, they're not going to tell you the x-axis. They're going to say the line y is equal to 0. You must know that that's the x-axis they're talking about. If they say using a line y is equal to 0, you must know that they're talking about the y-axis. Do not let these things be the things that make you fail the question or answer incorrectly. All right, so let's keep it moving. So we got translation, reflection. The next one is rotation. And the next one after that is enlargement. Now these 2 is the 2 I gotta do Steve with separately, because yeah, it's a bit more tricky. So we're gonna come back to these two. So let's get it started. Everybody know what rotation is, first of all. If you rotate this way, what type of direction that is? Clockwise. If you go the other way, it is called anti-clockwise. Next thing you need to know quickly, let me just do this one time so when we start doing it, y'all have the basics. If an object is here and I rotate it here, anybody know the angle that it was rotated? It must be 90 degrees because it must take 90 degrees to move from each quadrant is 90 degrees. Everybody see that? Yeah. So if you, let's say you rotate something and it end up here, how much is that? What is it being rotated by? Excellent. Excellent. One of the things too, when you're describing a rotation, you must state the angle. You must state whether it's clockwise or anti-clockwise, and you must state the point or the center of rotation. We're gonna come back to all these things. These are just things I want you to keep up for. You must say the angle is being rotated, whether it's clockwise or anti-clockwise, and 3, where is the rotation happening from? The center of rotation. And when it comes to enlargement, you're just increasing the shape by a certain factor, and the factor is K. If the K is greater than 1, what you think gonna happen to the shape? Again, bigger or smaller? Hello? If I tell you K is greater than 1, we applying a constant to a shape, and let's say K is 2. What gonna happen to the shape? It ain't gonna double if it's by 2. So it's getting bigger. If K is greater than 0 but less than 1, anybody know the numbers that fall in between here? Let me see who thinking. What type of numbers fall between 0 and 1? Excellent. Fractions, yes, decimals. Everybody see that? They're positive because they're greater than 0, but they're less than 1, which means it's not a whole. So anything a half, a third, a quarter would shrink the size. So we're gonna come back to these things, okay? There's an element where if the number is negative, that's the third part, but I need to show you using an example. That's the next part I'm gonna show you. Okay. All right. So let's get into the actual question. Are you ready, guys? Are you ready? Remember, we're learning as we go. The purpose of this is so that if it comes, you try to get as much marks as you can. Okay. We're trying to see how much marks we can get. You're not going to give up on the question. Even if you don't understand every single thing, try to understand and pick up on anything that you can. So let's go. We have question number 1. The diagram shows us x1, y1, z1, x2, y2, z2. Which one comes before which? The one on the left or the one on the right? So that's important to note. The one on the left. Is the original picture here? The original picture is not here because the original picture would just have x, y, z. Everybody with me so far? All right, so let's read the question. Triangle XYZ is the image of the triangle XYZ. An image, if you remember, is the word that they use after something is done to the original object. So object, let me just make sure I take note of this. Object is the original. Image is what happened after something is done to it. Okay, if you got it, say got it. Good. So based on what we see here, we understand what this sentence is telling us. It says triangle XYZ is the image of the triangle, the original, after an enlargement of scale factor 2 with center 5, 1. So what do we realize here? These two pictures are what? Bigger than the original triangle. Draw triangle XYZ, the object, which is the original for the triangle on the grid above. So let's go. What do you think is the most important part here in identifying the center? Can we identify, because this is the next thing, students, I'm going to show you what students is confused. What variable or coordinate does the 5 represent? The X or the Y? The X. And 1 represents the Y. Don't ever do this. That's not the point, because this is correct. This is 5, 1. So don't do this. Sorry. Everybody see what I'm trying to show you? The difference between the two? This one and this one. Which is the correct one? The first one or the second one? Which is the correct one? Which is the correct one? And this has happened to students all the time. Keep in mind, where's the X? So that means this needs to be the 5. You see, this is the wrong one. Remember telling you, don't make that mistake. Don't go do this and think that's the right one. These are the basics that we have to avoid making mistakes with. All right, so we have our center. What do you think that means? If anybody remember, anytime it comes to enlargement, enlargement happens within a range. You know what the range is? You connect each point to the center. So that's the first thing we're going to do. Unfortunately, you see what happened in here? I could never get lined up, so work with me, okay? Everybody with me? Just work with me, pretend like it connecting. It's going to be off a little bit, but in your exam, you should be able to make it match completely. So for each point, you line it up. Okay, we got that one good. So what do you think? What do you think gonna happen? Isn't the triangle gonna fall in between this range inside here? Everybody see what's going on? So if you were to, let's say they gave you the shape originally. Let's say they give you the shape originally and you had to make it bigger. You do the same thing. You use the point of center point and you expand it out and then you calculate where your other point's gonna be. Everybody with me? Only one person saying yeah, you know, and she say yeah twice. All right, so let's keep it moving now. If our shape doubled, what does that mean about the original shape compared to this one here? Isn't it going to be half? Talk to me, talk to me, talk to me. Hello, 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 hello. So guess what we need to do then? We need to find halfway between the center and the enlarged point. You got 2 ways you could do it. So I'm going to show you both ways. I'm going to show you the way to calculate and I'm going to show you the way using the graph. Everybody ready? So on the graph, I'm going to count how many boxes does it take from here to here. So this would be 1, 2, 3, 4, 5, 6. Everybody with me? What is half of 6? 3. So guess what? If this is y1, guess where my y gonna be? In here? Y ain't gonna be here. Everybody see what I just did there? Let's do the next one now. X, how much boxes? 1, 2, 3, 4, 5, 6, 7, 8. So where would X be located? At 4. So 1, 2, 3, 4. Boom. Everybody see how easy it actually is? I like to show using the graph because when you do the calculation, you can make mistakes and you can calculate or add something wrong. But when you use the graph, you're seeing everything. You could figure it out just by looking and doing your little movements. Everybody see what I'm showing you? So let's find Z now. So this is X. Let's find Z. We're counting how many spaces? 1, 2, 3, 4, 5, 6, 7, 8. So it would be again 4. 4 ends up right here. Let me count it. 1, 2, 3, 4. Right? What y'all realize going on here? Everybody see how we did that? And which way did we use? Watch the calculation way here. Let's be real. Anybody trying to go through this? No, for the purpose of making sure you understand, when we did graphs, remember we learned how to find the midpoint of certain things. Everybody remember this formula here? X1 plus X2 divided by 2, Y1 plus Y2 divided by 2. So essentially, the calculation method is taking the center and each point, adding them and dividing by 2 to get each point, and then you plot it after. So that's the 2 different ways. So let's go again. The first way, you literally draw your lines, count the spaces, find half. And that would allow you for each line, each red line, you find the point using half. The calculation way is adding the point center, the center point, and each point dividing it by 2. And that can give you an X and Y value of your original image, and then you plot it. So if you got this, tell me you got it. And then 2, tell me which one you prefer, graph or calculations. So I just want to take this opportunity to show you that we've done an enlargement. Look at that. Just like that from scratch. Everybody see how we just did that enlargement? And just to remind you, what was the important steps? Find it. What did I find first? What did I find first?
Miss V?
Yes.
For when you counted 6 and you said half is 3. But when you said it's 3, I'm seeing the point on the 4 on the 4th line.
No, you don't count the point, the line, you count the spaces. So look at it. Okay. 1, 2, 3.
Okay. Okay.
4, 5, 6.
Okay. That is where I got confused. I am plugging I have my paper, but I kind of got confused there.
Yeah, you get it now?
Yes. Okay.
Everybody see, and that's why I did the jumping. So the first thing you do is identify your center. That's the first thing. Boom. Second thing, you connect each point to the center. Now, if it was you were getting bigger, what do you think you would have had to do if you was getting bigger? Our lines would have had to go on with aim further out. Talk to me. Everybody see that? And even with that, look at the opposite. Look at the opposite. Here we had 3. And if we wanted to double it means that we'd have had to count to how much in 6. So you should be able to go back and forth. If it was getting smaller, you know what to do. If you're getting bigger, you know what to do. I recommend using the graph method because watch how fast we were able to do that versus having to calculate every single point. Anybody got a time for that? Yeah, because I uploaded all the links for the week. All right, so everybody good to go with the enlargement. That was a perfect example of a reduction and an enlargement. Okay, so let me take it from there. Next one, next question. Triangle X, so we have the original triangle, which was this. The second one they gave us, but it was the enlargement. And then we have something else going on here. So it says here, X1 is mapped on to image 2 or image 1 is mapped onto image 2. And anybody could tell what we're going on here already? Which transformation is this? You can look at it and see. Let me go back to the original. Let me erase all of this. What is happening between these two? Which transformation is it? Because that's the next thing I can't teach. I could only try to show you. Which one you're seeing? Is it translation? Is it rotation? Is it reflection? It obviously not an enlargement because both of them is the same size. Look at it. This ain't a reflection. Look at it. Watch where Y is, Y is. Look where X is, look where X is. Look where Z is, look where Z is. And based on what we learn, how do I find where the line of symmetry is or the reflection line? Anybody could tell me where the reflection line is? I don't even want to know the question. I want to see if you could figure out these things by yourself first. What is the equation of the line that reflection is happening in? And I just teach you how to name lines going downwards, because obviously it got to be a vertical line. So which one? How do we determine that? We first need to identify the two Y points. So let's go. Identify the two Y points. Isn't the line of reflection going to be in the center? Because the distance between two of them must be equal. Talk to me. How do we find something in the middle, the center? Find out how much space is in between and find half of that. So let's see how much space is. 1, 2, 3, 4, 5, 6. So that's easy. I need to separate 3 on each side of the line. Talk to me. So this would be 1, 2, 3. That means my line 1, 2, 3 ain't gonna be here. That ain't my line of symmetry. And if we were to count it, look at it. How many spaces in between? That's 1, 2, 3 spaces. 1, 2, 3 spaces. And you could do it for all. So let's do it for all. Let's connect all and then see if it's equal for both sides. How many spaces on this side? 1, 2, 3, 4, 5. How much on this side? 1, 2, 3, 4, 5. That's the center. Everybody with me? What's the name of this line though? Because that's not my question. What's the name of that line? What's the name of that line? Nobody? They saying the line X is equal to 2. Watch where the line is formed. They saying the line X is equal to 2. Hello? Everybody seen it? This is not what CXC asked us. I just want to make sure we seeing and we learning and we understanding the basic principles, because transformation isn't hard. It's just tricky, especially if you use the calculation method. So let's get back here. So what the question asked us for? It says image 1 is mapped onto image 2 by a reflection in a line P. State the equation. Oh, Jesus. Oh, Jesus. Look at that. Hello? Y'all see now? Hello? Y'all with me? These are things we should not hesitate for. And you know the standard lines you should be looking for. So let me go back down here when I was showing you the different lines you should be looking out for. You should be looking out for the lines, whether it's the x-axis or the y-axis, and we know the equations for those two, right? We should also look out for the line y is equal to x, and we know how that should look as well. We should look out for lines that is the y equal to the minus x. Then we should look out for any vertical line. Any vertical line would be x is equal to whatever number x it fall on. Similarly, any horizontal line would be y is equal to any y number it falls on. You see, there's a reason I've been highlighting these important facts, because that's it. Once you know that, you're good to go. And look how easy we get a question. So P is why x is equal to 2. Everybody got it? And guess what? That's a whole question number 3. That's it. So look at an entire question 3, which was in January. What did they ask us for? Line of symmetry, rotation, lines of rotation. They asked us for the missing angles in a basic diagram. Then they gave us a simple transformation. And which 2 did we focus on? We focused on an enlargement or a reduction and a reflection. Okay? This was easy, to be honest. I doubt the question coming this year going to be as easy. So we're going to just continue into another one. So there we go. Here they gave us, this is what year? Let me just confirm. January 2021. Okay. So now that we understand certain things, let's take a look at this one. So they gave us 2 diagrams. And it says select the word from the following list to complete the statement. Now, I taught you all of these words. Everybody know what opposite mean? But let's be real, since we're doing this, the word opposite is applicable in transformation. Have we spoken about anything about opposite? No. So this is a random word to throw you off. Yeah? Reflected, we understand what reflected is. Is this image reflected? Nope. So it's between these 2. Anybody remember the word congruent? When we were doing paper 1, I write it about 3 times, and I know for a fact I write it 3 times. Who remember what congruent means? Excellent. Yep, the same. Remember when we had the triangle in the question, the big triangle and the small triangle, and they gave us 7 and they gave us find the missing side, and it was 3.5. If you just attend most of the classes, you're gonna know what I'm talking about. Congruent means it is the same. It has the same properties, the same composition. And then you have translated. We know what translated means, right? What translated mean? It moves left or right, or up or down. Which one you would pick between the 2? Because they gotta be one of them. Congruent thing. And but let me see before I talk. Which one would you pick, guys? Yep, that's the answer. The answer is congruent. Because if this gone up and down, how come it flipped to the side? Translation does not flip an object. It just move it. It's like it's sliding across. So the composition would be the same. So it must be only congruent. Everybody see that? Congruent. It says here, give reason for your answer. So let's look at the reason. The 5 sides of P are equally linked to the corresponding 5 sides of Q. Hence, the figure is congruent because the size is proportional. Right or wrong? If you're in the exam, you flip your paper, you would see that both of them is the same. Same angles, this length and this length is the same. That's what we call congruent. It therefore say, or we may say that both pentagons have the same shape and this exact in size. So the areas are both equal to, nobody care about the area, but yeah, everybody catch the point. So everybody understand that? I feel like something like this might come. They're gonna give you some kind of object and they're gonna ask you to describe what happened into the object. Is it being enlarged? Is it being translated? Is it being reflected? Is it being rotated? These are things we got to be aware of. If rotated was here, it could have been rotation in it. Maybe. That would have been a better option than translated. All right, so guess what they give us again? Another shape. Oh yes, because you're doing an SBA, you don't have to do paper 3. You're only doing paper 1 and 2. Paper 3 is the devil. It's like the worst thing ever existed, okay? So you don't have to worry about that. All right, so let's go. let's take a look at certain things here. Based on what I've taught you, they will always give you a statement and an image. Before you begin, make sure that all the information that's in the statement is in the diagram. Everybody with me? You don't even look at the question yet. So verify that everything in the statement is shown on the diagram. So it says here, diagram not drawn to scale shows a pentagon. And do we know the different names of the polygons? Tell me the truth. It's 10 polygons. Do you know all 10 polygons? I'm watching the answers. Okay, I have enough nodes to go through it right now. So let's go. What's the smallest polygon, first of all? What's the smallest type of polygon? Excellent. 3 sides. Triangle. Like I said, please make sure you know all the different types of triangle. Isosceles, scalene, equilateral, right angle. Okay. 4 sides, what we call 4 sides, quadrilateral. Don't judge me with the spelling. 5 is what? Pentagon. 6 sides is hexagon. 7 has 2 names, so make sure you know 2 of them is either heptagon or septagon. Okay. 8 is easy. 8 is octagon. 9 is nonagon. 10 is decagon. Okay. Also, we should remember the name when they say a regular. When they say a regular polygon, what does that mean? What does a regular polygon versus an irregular polygon means? A regular polygon, all the sides are equal. A irregular polygon is where all the sides are not equal. Everybody with me? So we shouldn't have a problem with the names of polygons now, okay? All right, so let we go. Now, before we get into this, anybody seen a parallelogram inside of this? It's not a parallelogram because a parallelogram got 4 sides, but there is a portion of a parallelogram inside here. Tell me if you've seen it. So for those who may not be seeing it, I'm just gonna highlight it quickly. This is the almost parallelogram here. Everybody see that? And remember when we did the rhombus, what did I identify in the rhombus? That the opposite sides in a parallelogram ain't equal. So this and this would be equal and that would be equal. Everybody with me? But this side wouldn't count because we realized this side is not the parallel side. But for these two, it would count because if you look at the diagram, doesn't it still fit into the parallelogram section? Everybody see that? All right, so let's go into the question. Determine the value of WXY. Where is that? That's the first thing. WXY. We just talked about this before. That's this angle here. What piece of information could help me with that? Anybody seeing the co-interior angle? This ain't 2 parallel lines here. So 2 angles inside on the same side, what are they? The S word, what are they? Thank you. Supplementary. Thank you. Everybody see that? Just one question ago, we did the same exact thing. Look at here. Didn't we say R and Q? The in between, watch the parallel lines. The in between the parallel lines. So on the same side. So that means they add up to 180. Everybody realizing what's going on here? Because if you don't see it, you can't find it, you know. You got to look. Once you see parallel lines, these are the things should come to your mind. Co-interior, vertically opposite, corresponding or alternate angles. That's how your brain should be working. And you see which ones you see and could find. So obviously, how do I find this angle then? This angle would be what? 180 minus 114. You get 66. Hello? Look at here. Co-interior. And watch how they put it. Watch how they put it. You realize they make sure they state it that both of them add up to 180. And you realize they say why? Co-interior angles. And then they do the workings to show they get the answer. Yeah? So in your picture, you're putting your 66 degrees, right? Which one they ask us to find next now? So let me just put this here. I like to use my blank slate to make sure you are seeing on your own. Question 2 ask for ZVW. Z, where is that? ZVW. That's what they ask for? ZVW. ZVW. How do you find this though? Is this a direct question? This is not a direct question because guess what? This line here ain't got nothing to do with the parallelogram. This is not a parallel line, so we can't use nothing that we used before. But what can we use? We could use the idea of all these angles in a pentagon add up to something, and we should know how to find that. So if we could find this angle, everybody see what I'm trying to show you? And we know this angle. What is this angle here? What is this angle here? Nobody? Very good. 114. And so let's look at the explanation. We know that the angles, and this is the formula I need I hate this formula. They could have used a better formula. There's a better formula. Let me tell you what the formula is now. Give me a minute there. The formula is sum of angles in any polygon. Everybody copying on this formula, please. This is how to catch. This is okay, but is a lot more work. There's an easier one. It's 180 and minus 1, I think. Hold on there. So the formula is n minus 2, 180 times n minus 2. And to be honest with you, if you expand this, you could literally get this, to be honest with you. Because check this out, right? Let me do some quick maths. Everybody watching? Y'all with me? Only 2 persons saying yeah. What's going on? This is something very, very important. This is very, very important. How do I get this formula to this formula here? If I look at this bracket, I could factor out something in it. What can I factor out? Excellent. 2. Thank you very much. Everybody agree? Yep. So when I factor out 2, what do I end up left back with? N minus 2 times 90. How many things being multiplied here? That's a question for everybody. How many things being multiplied here? And I'm not moving on until I get majority of persons responding. How many entities or terms are being multiplied here? So that's 4 persons, 5, 6, 7, 8, 9, 10, 11, 12. All right, I'll take that. Guys, it is 3. This ain't mean 2 times everything in the bracket, so that's 1. This is the second thing, 2. And this is the third thing, 3. I just ask these questions for a reason. So this really means 2 times n minus 2 times 90. And there's a law that tells me because I'm multiplying, I can switch up the order of multiplication. So I could say 2 times 90. What is 2 times 90? 180 times n minus 2, which is the same thing as saying 180 open bracket n minus 2. Everybody see that? I did this because it's important for you to understand the connection between things, okay? So just erase, this is not for you to copy down. The only thing I want you to copy down is the formula. Any polygon that you have, you need to remember this formula here. You could calculate the sum of the angles from that polygon. You already know triangle. You know, triangle is what, 180. You know, quadrilateral is 360, but you don't know the rest. So you have to calculate it. And what do you think n represents? The number of sides. Everybody see that? So we could calculate the number of angles in an entire polygon, in a pentagon. That is 540. So what does that mean? If I have 4 out of 5 angles from a pentagon, can't I calculate the last one? Just like what we just do when we're trying to find a missing angle in a triangle or in a quadrilateral. So we're gonna say what? 540 minus the sum of all of the angles that we have here. And that's what they did. So look at the point here. You are expected to know that, because this is how far you got. They didn't ask us for this angle here. Let's go back to where we were. This is where we were. And they asked us for this. You need to say me, that is, I can't use no rules. I can't use the angle rules because these 2 angles are not opposite in terms of a parallelogram. So it can be 66. And if you look at it, what type of angle is this? This angle is an obtuse angle, right or wrong? So we cannot use any rule to generate that. But looking at everything else, I know that this and this is the same. And I know how to find the sum of all angles. So it would allow me to then find the missing angle. That's the line of thinking you need to have. All right. If you got it, say got it, because we're going right back into transformation. One of the things I want us to, yep, I did. I gave that.
So in this case, when we're doing a pentagon, we must remember that everything add up to 540.
I don't want you to do that. I want you to remember the formula, because let's say it's not a pentagon. Let's say it's a.
No, I was thinking of the pentagon.
Yeah,
the pentagon I was speaking of.
Standard, yes. To be honest.
Yes, okay. To be honest, making sure that I have the 540 just in case it's a pentagon.
Yes, yes.
Okay.
Yeah, I want to calculate the rest of them. No, I don't. I was gonna do that, you know. I was gonna do a table where we calculate all of them, but because let's say come in paper 1, at least you remember them or have an idea of what they are in it. But let's finish this question first. So somebody remind me, and we're gonna calculate all of them. So let's do this question first, or should we do it now? Because you know, let's forget. Because me 80, you know how my mind is work. So let's go through it. Let's go through it. Let's go through it. Calculator people, let me go, because we need everybody to be on top of this. So triangle, we're gonna put sum of angle So let's just do a quick table here. Let's do a quick table here. So everybody copy this down, because to be honest, this could come in a paper one question. Would it be like, oh, the sum of angles in a pentagon is what? And some people might pick 800 and I would die. So these are things you need to remember. So triangle is the first one. We know that. The sum of angles in a triangle is 180 degrees. The next one is a quad, pent, hex, hept or sept, oct, nonagon, decagon. All right, so let's go. Quad is 360, and you should start picking up a trend, you know. Anyways, there we go. Let's go to the side. This is the formula that you need to remember. 180 times n minus 2. For a pentagon, we know it's 540. So there we go. Next one is a hexagon. So that means n is what? N is 6. So it's 180 times 4. Right? Somebody? 6 minus 2. So what's the answer? People with calculators, what are you doing? Remember, we need some quick fingers, you know, let's go. 720. Anybody picking up anything yet? Anybody picking up a pattern yet? I teach you how to pick up patterns, you know. Look at what's going on here. We're going on between here and here. We're going on between here and here. We're going on between here and here. So let's do the next one. 180 times what? Septagon. Septagon would be times 5. Anybody realizing what I'm trying to show you? No, look at this. Look at the table. Each line is plus 180. So the difference between each polygon that are consecutive is 180. Hello? Check it to see. Put 360 minus 180, you see you get 180. Put 540 minus 360, you see you get 180. We're going to continue, you know. So this one was for what? This one was for the hexagon. This one was for the hep. So if you add, you're going to get what? 900. Somebody check that to see if it's true. 180 times 5 is what? Is it correct? So let's go. What's the next one then? Thank you. 1080. What's the next one after that? We got 17 people in here. We need to keep it moving. Let me go. Next one. Yup. So copy this down. When you're done, say done, and we're gonna keep it moving. Now, for those who are here, please note the schedule for the rest of the week. This week is our last intensive revision. When I say that, I mean this is when I'm gonna be teaching things that like you probably didn't know before, or covering any nooks and cranny, all these things, right? But from next week is just past paper. So tomorrow I am going to be doing construction. So that is constructing a triangle, constructing a parallelogram, bisecting a space, questions of that nature. Like I said, they have not brought a construction question in a while, But the truth is, based on the pattern, they didn't bring any construction in January, so they may not bring any in June. But I prefer to teach you than not to teach you. So Monday's construction, Tuesday's question 6, Wednesday's question 8, Thursday is our last paper 1 question session, where we're gonna go through paper 1 from beginning to end. And then Sunday, I am going to do some summary notes on question 1, 2, 4, 5, and 7. So just quick summary, things to remember, especially with statistics, making sure you remember how to draw a histogram, how to draw a cumulative frequency curve, how to find the mode, median, mean, stuff like that. So it's just revision, 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 revision. Now, y'all know the 2nd of May is what? Labor Day. That day, I am dedicating solely to my students. I am going to make myself available from 9 a.m. to 6 p.m. Each student will be given an hour by themselves, alone. But it's going to be online though. When I post the schedule, it's first come, first serve. So whoever pick the time first, get it time first. So start organizing yourself, figuring out which time you may want. And that is the time you get to go through any question you need. Anything you want me to go over 1,000,000 times, I'll go over it 1,000,000 times with you. Okay? So that's the is Labor Monday? What Monday that? May even know the holiday itself, but the 2nd of May, that's the holiday, yeah. So the Sunday, I'm gonna do that too. I'm gonna do it the Sunday and the Monday. Me going online, I'm not gonna work, I'm not gonna take no jobs. That day is solely dedicated to y'all. So y'all let me know if you want it. If you don't, leave it for the students who can take it. Everybody with me? Just confirm quickly. Please make use of my offers. Okay. All right. And then from there, the classes we have the week after is just past papers, past papers, past papers, past papers, past papers. Now I know those who are in 5th form, you have exams almost every day that week. So I don't expect you to come to class during that week, but whenever you can, try to. And then the Sunday and the Monday and the Tuesday just before the exam, we're going hardcore. Okay. All right. So let's continue into our session. So before we start, I need y'all to tell me how you're feeling about transformation so far. How you feeling about what we've done so far. I realize a lot of people weak areas is functions too. So I think I'm gonna dedicate a session on functions, relations, and graphs. Yeah. So yeah. So everybody talk to me, let me know how you're feeling so far, especially with what we've done so far with the transformation. The tricky part is really the when they start talking about the matrix. I'm gonna be honest with you right now. Anytime they ask you for any matrix, just skip it, because I need like 3 weeks to teach that alone. And I can't teach that in a day worse right now. Everybody understand what I'm showing you? So anytime they ask you for any matrix transformation, just don't even bother with that. That's just 2 marks, 3 marks. You lose. Just keep it moving. Keep it moving. Focus your energy on everything else. All right, so let's keep it going. So here we have a letter A. See, this is very interesting. They didn't give us a shape, they give us a letter. And a point C. And everybody could guess what you think this C represents. What do you think this C represents? It is. C represents our center of something, okay? Whether it's an enlargement or a rotation, it's a center, right? On the diagram, draw accurately each of the following transformations. So let's see what the first transformation is. The enlargement, I love it, of letter A by a scale factor of 2 about the center 6, 6. So luckily for us, they gave us this already. If be honest, how much people think y'all can handle this by yourself even before I do it? Is there silence? Kind of. Not so confident. Nah. I have to send out some gangster juice, you know. I need some gangster juice over there. We just did this. Stop being punks. Let's go. We understand what scale factor of 2 is. We just do this. It's the same question. So that means the shape is doing what? If it's a scale factor of +2, what do you know this means? What happening to the A? In doubling. That means we're multiplying everything by what? In 2. It getting bigger by 2 times. Hello, let's go. So step 1, look the work in here. But let me go to the blank one. See, what was step 1, guys? And identify the center, but they gave us already. For each thing I say, I need you to tell me got it or don't got it. Because y'all, let's doubt yourselves and moving like some punks. But we ain't want that. So let we go. If you understand the function of the center, say got it. That's 1. And be honest. If you don't got it, you don't got it. So be honest. What we remember from the one before, what do you do with it? What do you do with it? You have to take the line and draw it through the point and expand it out. Then what we talked about before. And because it's an enlargement. A question like this is probably 3 max. But based on what I'm doing, everybody remember us doing this before? Then the same thing that we're doing. For each point, you're drawing out your enlargement lines. And your enlargement line starts at the center and goes through each point. Let me identify all the points. Or the major points, I should say. The major points. This, and this. That's my major points. So I see some person saying don't got it. So give me some heads up now. Do you understand the first step of what you should do when you're enlarging something or shrinking it? You use the center, the point of center, and you expand your enlargement lines. Let's call this our lines of enlargement. So Ozzy, Alicia, talk to me. And all the others, talk to me. You understand this part? You just take your ruler, you take your pencil, you connect the point and connect it to each point. Okay, so what does that mean? That means that what? That our A ain't gonna fall in between here somewhere, in between these lines. Good. They tell us our scale factor K is what? Is what? 2, right? That means we're getting bigger by 2. So let's look at this. Let's call this the top of the A. How do we find the bigger top of the A? What do we do? Isn't it going to follow along this top line here? So we're going to find the top of the bigger A along this line. Everybody with me? But how? We have to identify where double is going to be. So let's go. If this is how much space is, 1, 2, where would I find the double A located? Where would that be? In at 4. Talk to me. So that means 4 jumps, right? So this is 3, this is 4. So wouldn't this be the top of my A now? Remember, we're using the graph method. And what are we doing? We're multiplying each space by 2. If we count a certain amount of boxes here, we just got to count double for the bigger A. Everybody see that? So let's do the next one. Let me zoom in a little bit so we can see better. So let's count how much space is for the second one here. So this would be 1. This would be 2. Sorry, I'm using the wrong line. And remember, I'm using this computer thing, so it's kind of tricky. So let's go. This is 1. This is 2. Yes, we did. I don't like how my line look. Let me use the actual lines from the thing so we could see it properly. So let's count it. 1, 2, 3, 4. Everybody see the 4? So I'm gonna use this one because it's a lot clearer. 1, 2, 3, 4. So how much do we need? 8 in it. So we need 4 more. 1, 2, 3, 4. So we done count this one already. So everybody, let me know if you understand how I'm doing the counting. Everybody seeing the spaces that I'm counting? Let's try the other one. Remember, you're counting the boxes, eh? So let's go. So from here to here, that's 1. That's 2. That's 3. That's 4. T, you see how I got the 4? I'm counting the spaces, the small boxes that in between. How much do I need now? I need 4 more because it's 8 I need in all. So that's what? 5, 6, 7, 8. So that's where my next part of my A gonna be. See that? Same thing with this. Count 4 more. 1. You see, you know the reason why I hate this? Y'all realize this line went off by a little bit. Y'all see that? You see why A matching up? So that's why I went over here, because these lines are exact. So when you count it, you're gonna end up with your 4. And obviously, if it's one space between the A here, because it's double, it's gonna be how much down here? In 2. Because everything double. And you form your letter A. So now that we did a second example, do you think you could do this on your own? So step 1, use the center, connect each point, draw a line through each point, but because you are enlarging, what you're supposed to do with your lines, make them longer. So instead of bringing it just here, you bring it straight down. Obviously, you can probably bring it a lot more down. Everybody see that? My thing never match up, but y'all get the point. Yeah? Okay. So again, based on this, we see here that's how you're gonna get it done. Enlargement or shrinking. I hope they bring an enlargement, to be honest. If they bring an enlargement, I would feel pretty good. And here are your notes. Like I was saying, we draw a straight line from 6, 6 to each of the 3 endpoints of vertices of the given figure as shown in the back. Then we extend the lines shown 2 times their lengths. So you know what I like about this? Y'all realize the exam before they use the calculation method. What method they use here? In the graph method. Like the same thing we just do. So I thought they would have did the same thing. But look at it here, and that's why I'm saying you could study from fastpass.com. You could learn from it directly. Okay? And you see here, all of the measurements are taken from the center. Good. Anyways, let's keep it moving. 2, we need to do a translation of letter A using the vector this. Let me ask this question here quick. What type of movement is this? What type of movement is this here? Let me see who remember the things we spoke about earlier and previous classes. The first term always represents what? In the X. And the bottom one represents what? The Y. What did we say when X is negative? What direction is that we move in? Remember, this is a translation. So that means the image is sliding either somewhere, left or right, or up and down. So let's go. That means the image is shifting 3 times to the left. Everybody see that? What about what type of Y movement we get in? Up or down? Up how much times? 2 times. Hello? Y'all with me? So in this picture here, let me see if I could do it here. So we're going 3 to the left. So every point, let's do that. Every point, let me just make sure I memorize it. See, 3 to the left, 2 up. So every point is the original A, going 3 to the left and 2 up. So let's call these points here like that. So let's call this A, let's call this B, let's call this C. So let's go 3 to the left and 2 up. That's 1, that's 2, that's 3, and 2 up. So A gonna end up here. That's A1. Everybody see that? Let's do B. B going 3 to the left, 1, 2, 3, and 2 up. 1, 2. So B1 is here. C now, 3 to the left, 1, 2, 3, 2 up. 1, 2. And what do you do next? You just connect your points. That's a translation. And if you remember, we did this in vectors. If you got it, say got it. And guess what? That's the end of the exam, people. Look at that. Look at that. And be honest, is anything about this too hard for you? It is not. You just gotta remember your basic concepts. What does it mean to be translated? And the information using the vectors. What does it mean to be reflected? What does it mean to be enlarged? You realize which question they give us it? You realize no rotation here? Because CXC does bring rotation when they savage mode. You realize we did all 3 except rotation? So this is another paper out of 10. Rank your understanding, please. We're gonna do one more. I'm gonna look for a rotation question. And then that's the last question we're gonna do for the night. So I'm watching your rank. I'm watching your rank for your transformations. Okay, not bad, not bad. And one of the things I need to know if you're feeling a little bit more comfortable with it now, because we would have gone through it before. And I know it was a bit rough. Oh my God, this is the rotation. I feel stressed already. But we're gonna try. I'm very happy to see the comments. Which part, rough, Janela? The what we did tonight mashup, or you mean what I'm showing right now? Oh, I just want to quickly show y'all something just in case. Let's say they gave you the 2 points, the 2 images, which is the original and the enlargement, and they ask you to find the center. Just how the first thing you got to find for the enlargement itself is to connect the points. You know, it's the same thing, right? So guess what you got to do? So I'm just doing this, to show you. You connect the 2 points and you expand it, right? So look at this, PMP are expanding. If this thing will let me live, let me choose another 2 points, see? Let's use P and Q. So let's look at P and Q. Everybody watching? This question asks us to find the center given the already enlarged object. So you use the same basic concept, connect 2 of the points. What do we know? That all of the intersections must be at a singular point, right? So obviously, after connecting all the points, we gotta find the point where they do what? And where they intersect. That makes sense? Everybody seen it? Everybody seen it already? Even though this stupid thing ain't allowing me to do a straight line, but everybody seen it already because I seen it. Everybody seen the center? Look at here. where the two lines intersect. So if they ask you to find the center, you know how to find the center, all right? I just wanted to quickly go through this because that's the only thing we did not do when it comes to the enlargement. And another thing is I wanted to show you guys what happens when your enlargement is negative. But none of these allow me to do it because you can't really see. Let me see if I see any. No, I don't. But let me just do a quick sketch so that y'all aware, at least aware. Now, y'all know, right? When we're doing enlargements, what do you realize? The enlargement don't be on the same side of the point. Y'all see this? Y'all realize the enlargement always on the same side? This is when K is positive. But let's say K is negative. If K is negative, when you're doing your enlargement through the point, you don't expand. Sorry, let me use this one here. Let me use this. So as I was saying, you see how we did this enlargement and both of them is under the same side of the lines? If it was a -2, right? Watch what you would have had to do. If it was -2, the negative side sign makes the enlargement go on the opposite side. So rather than expanding it this way, guess where you would have had to expand it? You do the same thing, but instead of coming over on the same side, you would have gone over on the opposite side. Everybody see that? But it's the same exact thing. Nothing else is different except the enlargement is on the a different side of the thing. So your A would have been here on this side instead of down here. So it would have looked like this. Let me use a red thing. Well, on there, I'm trying to determine how it would have been if it would have been like something. Y'all catch me drift, right? Everybody catch the drift? It would be an upside down because it's the inverse. So you would do the same thing. You'd count 4, 1, 2, 3, 4, boom. On the same line, you'd count 1, 2, 3, 4, same thing, and then connect the dots. It's the same thing, but it's just that that's what the negative sign would do. So I think now that we know. So let me just quickly do this. If you have a whole number, it gets bigger. If you have a fraction, it gets smaller. If you have a -2, it's getting bigger, but again, bigger where? On the opposite side. All right, yeah, that's all I wanted to make sure we clear up. So in case it comes, you know what to do. No, I am just going to read through this because I am not going through this drama with this rotation thing. We did this already, by the way, but we're going to go through it again. So this is our last question for the day. So let's look here. They gave us a diagram, a triangle with some angles and a side. It asks us to calculate the size of angle PRQ. PRQ. How do we do that? How to find a missing angle there? And it's so easy. Don't overthink it. What to do to find the angle? I just need one person to tell me. Excellent. Everybody see what he's saying? You add up these two and you subtract it from what? 180, because all 3 angles in a triangle add up to 180. Do you know some people would have gone and tried to do the cosine, not cosine rule, the trigonometry? No, because you have all 2 angles in the triangle. Okay, always go from the basics and then go up. All right. Simple. 180 minus the sum of the 2 angles, 28. Excellent. No, this is different. They want, so let's label it now. This is 28. They want length RQ. RQ. No, this is different. What do we do for this case now? Sorry. Let's label this X. How do we find that? Excellent. So one person told me in direct messages. Anybody else? Excellent. Is it cosine though? It's trigonometry, but is it cosine though? You can use cosine for sure. Everybody, so you could use both. Let's use both. If you use cosine, it would be what? Which angle you're using then? You're going to use the 28 angle, right? So you would end up saying cos 28 is equal to x over 11. And then you solve for x. Everybody see that? Remember, a right angle triangle is either Triggs or Pythagoras. It must be. Don't forget, Jerome, these are the only two rules you could use with a right angle triangle. Pythagoras, and we can't use Pythagoras because to use Pythagoras, not the cosine rule, cos, they're using the Triggs ratio. They're using cos theta is equal to adjacent over hypotenuse. This is the adjacent, look at it. Adjacent, and 11 is the hypotenuse. See it now? And if it was sine, what we would have done, it would have been sine what? 62 is opposite, which is x over 11. So everybody see how you could have gone about now? You could have used anyone, but it must be Triggs. Must be Triggs. I'm very proud that you guys are able to follow. For those who can't follow or don't understand, let me know. You see they use the sine one, corrected 2DPs. Please note, always give 2 decimal places for your final answer. Always use more than 2 in your working, okay? All right, that's an easy angle question. Oh my goodness. Oh boy, let's go. We got this. We're almost there. Once we get through this, we should be good. Triangle X, which is obviously the original, right? Is mapped on to, what is it, Austin, what's going on? Don't stress, we're going through it together, deep breaths. And the truth is, a question like this, you try to do as much as you can, okay? Triangle X is mapped onto triangle Y. So I mean, this is the original and this is the image by a reflection. State the equation of the mirror line. I don't want to have to fight nobody tonight, so y'all better answer this question. What is the equation of the mirror line for these two objects here? Excellent. You remember we spoke about this earlier, the equation of that. What is the equation of that? Nobody else want to try? Come, let's go, man. First of all, do we agree that the x-axis is the mirror line? Look at it. Do we agree with that? And the truth is, let's say you don't remember, say the x-axis. Well, how I again x is 2? Because look at this. If this is my mirror line, didn't I teach you the equation of the x-axis? What is the equation of the x-axis? Y is equal to 0. Not so? You remember, you see how much, you see the same thing I asked you tonight? Remember I said this before? Everything I say for a reason, okay? So I need y'all to literally absorb everything I mentioned. There's a reason why I emphasize the importance of knowing the equation for the X and Y axis. So while we're here, what's the equation for the Y axis? And look at it. The equation for the X axis is Y is equal to 0. So the equation for the y-axis is what? X is equal to 0. Lock it in your brain right now. If you got a hold it like you're scooping it up and shove it through your ear, do that. No. After tonight, I don't expect nobody to forget it. So I'm going to say it again. The equation for the x-axis is y is equal to 0. The equation for the y-axis is x is equal to 0. If you got it, say got it, because we ain't going through this again, eh? You need to make sure you grab up every mark you could get. And I'm telling you, I know when you're going to the exam, I have a feeling the exam gonna be rough. You got to go in with a rough mentality. Do not let CXC bulldoze over you. Mentally prepare yourself to fight through the exam. Get as much marks as you can. Read things, read it again. Okay? Again, look at all these notes here for you to read when you're studying. Alrighty, let's keep it moving. Next one, describe fully the transformation which maps X onto Z. So these two now, look at what's going on here. Let's do an elimination. Is this, we're looking at how this changed to this. Is this a translation, yes or no? Because you gotta go through it, eh? You gotta ask yourself all these questions. Which transformation is it? Excellent. So it's not a translation, because what do we know? The translation does not change the orientation. It would always look like this as a translation, right? So, you know, translation is out. Is it a reflection? No, it's not. What else do we have? Is it an enlargement? Obviously, it is not. So the only thing you got left is who? Who's the last one? You know it's a rotation. No. What are the three things I tell you need to describe a rotation? I told you three things you need. What do you need? You need the angle it's being rotated. Right or wrong? You need the direction. So you need to say what? It's either what? Clockwise or what? Or anti-clockwise. What was the last thing that we need? And it's similar to the equations before. The point, the center. The center, remember, we always need a center. So let's remember, rotation is the last thing we need to do now, eh? So this is our final thing. So let's go. Whenever you are describing a rotation, we don't identify how to figure it out. We eliminate all and you make sure that's the last option. When you're describing a rotation, you need to determine the angle. You need to say if it's clockwise or anti-clockwise, and you need to find the center. Based on what we're seeing, I kind of give you a hint. If you were to make a guess, what is the angle here? Let me see if you're thinking. We ain't even looking at the actual working. We're looking at estimating based on our knowledge. Excellent. Excellent. It must be 90 because we describe how we know it's 90. Look at what quadrant it is in now. Where did it go? It went to the next one. What is the movement from one quadrant to the next? In 90. So we're looking good. So far, we guessed the first one. We got to prove it, but we at least in the right neighborhood. And I hope everybody following me. Keeping in mind, each quadrant is 90 degrees. For you to shift from one quadrant to the next, you must have an angle of 90 degrees minimum to shift over. You check? And we spoke about, suppose we ended up here, what angle would that have been? A 180 degrees. Okay? All right. So I hope everybody with me so fast. I'm just going to take a quick second to just pause and make sure everybody with me, that they understand how we got the angle 90. Now, the next one is easy. Clockwise or anti-clockwise? Auntie. Boom. That, and to be honest, let's say you can't remember certain things, you must pick up a mark because you must remember at least these two. This one is the work part. No, I'm gonna be honest with you. This is the part you gotta put in some work. Okay, this is the part that's not easy. Find the center requires you using instruments and drawing lines and finding it. No, let me show you the concept we're gonna be working with. You see, when we were trying to find the center for the enlargement, what was one of the things we had to do? We had to find an intersection, right? Using our construction lines, right? No, you're going to use a similar concept. The only difference is, obviously, we don't use these lines in rotation. We use other lines in rotation. So let me pause right there. Everybody see what I'm trying to show you with respect to the intersecting lines? So when it was enlargement, we had to use the enlargement lines, and when they intersect, that's where we found the center for enlargement. When it comes to rotation, we have to use the rotational lines and see where they intersect. So this is the tricky part, finding the rotational lines. All right, so let's just use the notes because I'm like really exhausted. And I'm gonna use the notes to show you. So follow me, right? All right. Oof. Let me know if you're ready. We got this. We got this. We got this. One person ready. Two. Let's go. Let's go. Let's go. Okay. Remember, and I'm gonna keep making examples so you could make the connection in your brain. What did you realize we did here? What did we do? Didn't we connect the 2 points for the enlargement? Right? So guess what you have to do here? You got to do the same thing. You have to identify all the matching points. So let's say this is A. Obviously up here is A1. Sorry, if this is the original, sorry. So this would be the A and this would be the A1. So for me, even if CXC ain't give you no letters, find your own letters because they're going to help you see better. Agree or disagree? So if I call this A, this would be my A1. Let me look at the shape. I turn my head to the side to make sure this is the back. So let's say this is B. This is B. So this is B1. Make sure you agree with me, because sometimes, my eyes and I'm exhausted. So I just need y'all to verify if you agree with my labeling. My labeling look good? All right. So what do you realize they did here? Yeah, realize what they did now? Because this is where the difference is going to come in. The first thing that is similar to the enlargement is that they connected the 2 points that match. Everybody see that? But this is the difference now. This is the part that makes it different. Let's focus on A first. You have to bisect this line in half. And it is where each line, each connection, every time you make a bisect line is where all 3 intersect. You don't even need 3, you only need 2. So I'm going to tell you which 2 I'm going to use. I'm going to use C and I'm going to use B. So check this out. If you don't know how to bisect, I'm going to show you right now. So let me just pull up something here. Some stuff that we need. We need a compass. So for those, tomorrow we're going to be doing this. So please, if you don't know how to do this, please attend tomorrow's session. This is stress me out. The last time I did this, it was bare drama. So just work with me. So first thing first, I need to decrease the size of my compass. And when you are bisecting, I'm going to do a quick sketch for you. Let's say this is my line. Everybody following? So I'm doing a quick sketch without the protractor and without the compass, and then I'm going to try it. So first thing first, you got your compass, right? You're going to put the needle part here on one end, right? So this is the needle part here stuck. It's stuck here, ain't moving. Now this arrow thing, y'all seen my little dot thing not moving? Because me and if I seen what I seen, I'm just making sure y'all seen it. Y'all seen it, right? So this dot thing represents where your pencil be. So you open up your compass to more than half of the line, and then you draw an arc above and you draw an arc below. Maybe I should go on the side so you can see better. Sorry about that. So let's do that again. But this is important. Because sometimes it just give you spaces to bisect. I saw that in an exam and I was like, whoa. So let's go again. So I put my needle part of the compass here. I open up the compass. This is my pencil part. And I draw an arc above. Come down, and I draw an arc below. You move the point to the next side. You do not move. That's the next thing. You cannot move the width of your compass. It has to be the same. So let's say for some reason your hand shift and you change it. Go back over here, open up your compass, measure it, make sure it matching. Put the pointer, stick it in, and then you subscribe another arc above and below. Here, this point and this point should make a straight line that bisects your line. Now, obviously, my thing way off because it should be in the middle here. My bad. But you see what I'm saying? Everybody see what I'm saying? So let me do a better sketch. This should be more like here. This should be like more like here. Yeah. That's how you bisect anything. That looking like it, yeah. A little bit better. I know that's right. Okay, so this is the line now we call the bisector. And if you don't know, bisecting means to split something in half or to divide it into two equal lengths. So this is the stressful part. Do I need to use this thing, guys? Because it does a lot of work. Y'all understand what I'm trying to do, right? It just be like, how do you move this thing? Hold on there. Yeah, it's too much because I don't even know. Okay, good. So like I say, you put this here, you draw arc above. Jesus, help me. Then you bring it here, you do it below. Okay, I ain't doing so bad. I feel stressed though. You move it to the other side. Basically, keep the distance the same. You see that? Boom. Then you bring it. Oh, shucks. Help. Help. Okay. Bring it down. And then you take, oh God. Good. Okay. I think I do okay. You must use your compass. I have to use my mouse. So obviously, look at that. Oh, look at my thing and matching. Well, if my thing will let me draw it. But everybody see? If my thing would allow me to like, you see how the purple line is where you're trying to get. But you see, it just ain't letting me line it up properly. Because you know, the Babylon system just ain't want to swing at all. I use a stylus pen. Anyways, so as I was saying, so you bisect this line, boom, you're gonna end up with your first bisector, boom. Everybody see that? Then look at it, they bisect the B line, and it's really where those two bisecting lines meet. And in this example, where's the center? That in the origin. So let me go back before. When it's an enlargement, it's easier because you really just got to connect the 2 points and find where the 2 lines them intersect. This is the enlargement. You see why I'm going back and forth because I want to show you the similarity and the difference. So for the enlargement, you connect your 2 points, Q and Q, you extend it where those 2 lines intersect, that's your center. When it comes now to rotation, it's different. It's similar, you join the 2 points, but what do you have to do? You have to bisect it. And it's where the bisecting lines intersect is where your center is. And to be honest, that's it. That's how you find the center. I'm gonna take a deep breath. So how do we describe our rotation? Let's look at it. Look at it again. The angle, 90 degrees. Anti-clockwise about O, which we know is the origin. My mother's here. Woo. Be honest. I understand what I just do. If you don't, it's okay. Just tell me the truth. Which part y'all don't understand? First of all, do you understand the angle? Because let's be real. If we could get 2 out of 3, get 2 out of 3, to be honest. Like, ain't nobody trying to kill myself here tonight. So let's go through the 3 parts that we need. Did everybody understand how we got 90 degrees? Is the axe that confuse you? I know, yeah. Okay, let's take it step by step. And because y'all don't do technical drawing. Tomorrow when we do the construction, it's gonna make it a lot better. I'm gonna be honest, because I'm gonna teach you all these things tomorrow. So these things with the thing gonna help a lot. Because it's just a skill of bisecting something, which is something new. All right, everybody understand why it's anti-clockwise? So the trouble is, let me know, the hard part for you is finding the center. Everybody confirm if that's the problem you have. So in terms of the rotation, you understand the angle, you understand the direction, it's just finding the center is the problem. Okay. Okay. Yeah, because it's confusing here. I'm so sorry, guys. You want me to try it on this one then? Since it's cleaner? Want me to try one more time? I'm willing to try one more time. If y'all don't want to try, it's okay. It's all right. Okay, Austin says sure. Just to kind of give you guys a heads up, this next one is a translation, but everybody understand the translation, right? You just literally move in a direction. So you see this one is easy. It was a translation of -7, 1. So you just move across 7 to the left and 1 up because it's positive. So the translation one is easy. And then we see here, what do we have? Enlargement, and we don't know how to do an enlargement. So it's just the rotation. All right, so let's try again here, and then I'm gonna try my best, okay? I'm gonna try my very best, and then we just leave it if anything. Okay, so let's go. If you're ready to try again, just send me some good energy. Even if you don't understand after, at least we're trying. So just say ready, because that's where we're gonna end. We're gonna end it right here. And I don't want you to let one rotation throw you off with everything else that you did understand. You check, that's what real gangsters don't let these things throw us off. Okay, all right, so there we go. First thing first, we got 2 shapes. Like we said before, we should label everything that matching, right? So we're gonna label our A, our B, our B, and our C, and our C. Everybody understand this part? Good. I am going to focus on A first. So let me zoom in here. I'm going to focus on it. And I'm not going to use the compass. I'm going to just sketch it. Is that y'all okay with that? Or y'all want me to use the compass? Tell me no, which one y'all prefer. I think I should use the compass because that's what you got to use. Even though this compass big, how to make it smaller? It can't go smaller. It can't go no smaller than this. It ain't look so. But I'm going to try, okay? I'm going to try. So there we go. So before I use the compass, do you understand what I'm trying to do with the compass? What am I trying to do? I'm trying to find the bisected line, the line that has cut the A line in half. So make sure everybody confirm they understand what is the whole point of using the compass. Because if you could tell me you understand that and it's just the skill of using it, I'll take that. So I have 2 yes so far. What about everybody else? Because that's the part you need to make sure you understand. What's the point of me doing all of this? Okay. Hold on, there's somebody bringing something for me. Let me just tell them quick. Hello, good night. In class now, when you come, you could just leave the stuff on the land and I'll come for it after class. Hello? Yes. Yeah, nobody can go with them. So you could just put them on the land. Okay. All right, bye. Okay. All right. So let's go. We're going to take we time and we're going to go. Now, as we said before, we understand what we need to do to bisect. You got to put your point, your compass on one side at one point. Everybody with me so far? So you put your compass and then you have to subscribe and arc above and below the line. So that's what I'm going to do. I'm going to try, I should say. Give me strength. So I'm going to do one below, boom. And I'm going to do one above. Are you? Oh. Okay, everybody see that? So everybody with me so fast. Let me pause right here. Let's go, guys. Come on, give me energy, give me energy, give me energy. Remember, I need to see if y'all with me or not. So what have I done so far? I just literally use my compass to subscribe, but arc below and above. This is for me to make my bisector. So now what am I going to do now? Move the compass. I didn't change the size of it. I move it to the next point. Oh, shucks. And then I am going to cut the arc above and below. So I cut it above. Now I'm going to try get below and cut it below. Boom. Okay, we did that. We did that. What am I going to do now? Use my line and connect which 2 points? In this point here and this point here. Let me move this thing here. Everybody see that? So even though it's kind of big, because remember my compass couldn't get smaller, so it's kind of big. So my line kind of huge. And yeah, I realize what's going on here. It don't ever want to go exactly where it's supposed to go. As we know, why, yeah, where it's supposed to be. Because actually this line's supposed to be above, because in, oh boy, let's go again. From here, yes, to here, yeah. Okay, that's my best, that's my best. So everybody see how I got the first bisector? Please let me know if you're seeing it a little bit better and understand the process. So that's my bisector for A. I am going to do a bisector for C. So how do I do a bisector for C? First, I must draw the line C. So connect the 2 C points. And I'm going to do the same thing with bisecting 2 of them. But me going to do it the getaway because I am tired. I just cannot do it again. It's like a lot. So I'm just going to do this thing where I pretend like I draw a thing up here and a thing up here and a thing up here and a thing up here, and then we draw a line. Let's pretend. Anyways, the point is after I did it, guess what will happen? It should cross where? Both of them intersect where? Both of them intersect here. So this tells me where my center is. Okay, I don't want to cry, but if tell me if I understand a little better, no, please. If you didn't, it's okay. It's okay. But let me know if you understand a little better. You know what I'm saying? I try. I try. Okay, okay. So that's it. That's it. So your center is 0. Now, after you do that, you're done. And the next question was just to translate 7-1. And as we said before, we understand how to do that. 7-1, you move it. Okay, what's the next question? An enlargement by half. So what does that mean? Is it getting bigger or smaller? If it's a half. Smaller, right? That means it's shrinking by twice its size. Everybody see that? How did they do that? They didn't show us how they do it. Remember the center. Remember you connect to the points. Connect to the points. You realize that? You realize the points them connecting? And I sent it to the original, and obviously then the smaller would be in between it. So you do half. And that's why you get your points to get halfway. See, we did this before, so easy stuff. And guess what? That's it. That's it. I seen something here about matrix. Next, we don't do that. We do it the ghetto way. Sorry about that, guys. But you know, it's all about passing, working smarter. All right, so that's it for today's session, my God. Whew, out of 10, how you feel about everything we did tonight in terms of your understanding? So this includes reflection. I don't even want to count rotation up in there, but you know, I think we could handle rotation now. Translation, enlargement, and rotation. Even though rotation was the toughest one, I think we were able to at least get some progress with that. And so I feel we are good with question 3. How y'all feeling question 3 now? You know what to expect for question 3. You dig? Question 6 is measurement. Now, before you leave, let me explain to you how question 6 is the big boys. You big boys. Hold on there. I want to show y'all an example of question 6 because I spent all afternoon just going through questions, picking up trends, and understanding. For those who don't know, this is the FastPass website that you guys have access to. So everything I'm doing here, you have access to. And that's why I'm going through it now. So if at any point in time you forget or you feel shaky about something, you just go and pull it up, okay? So pick on January 2022. You're gonna load up. Then we scroll down. I want to go to question 6. Question 5 is statistics. Question 6 is, watch this nonsense here. This just upset me. Don't tell CXCS so. Look at this. How to scroll in, eh? Hold on. Oh, I could see. Yeah, seeing? What kind of monstrosity is this? Look at the monstrosity. Look at this thing that they gave us. Okay. Now remember, measurement is all about volume, area, conversion, etc., etc. So they're gonna tell you something about this container and the amount of figure thing in whole. And every year it like that. When I tell you every year it's some kind of thing that looks like this. Okay, Austin said too easy. Okay, big up yourself. But what I'm saying is that every year it's something different. Do not say that you're doing every question. You're gonna do every single question. It only look like this, but if you take your time and you know what you're doing, we're gonna go. So what day I say is question 6. Tomorrow is construction and Tuesday is question 6. So Tuesday, if you can make it class, please make it class. I don't think you want to miss this question drill. All right. Everybody with me? We tried a question like this before in class. Those who are in my fifth form, you have orals Wednesday, but oh no, if you got oral Wednesday, you can't come class Tuesday. So you just gotta look at the recording, okay? If you can't make it. But just make sure you watch the video after. And good luck in your orals. Ooh, if you got orals this week, good luck. Okay, guys, I know y'all got this. But that's it for today's class, everybody. For those people who want the past paper question answers, message me. Let me know. Big up yourself. Bye.